So let me see if I can kind of show you here through an illustration. Here I have a simple network with three clients, right? Client 1, 2, and 3. Client 1 has an IP address of 192.168.10.101. Client 2 has the same network ID and then 102. And Client 3 has a host ID of 103. These are all private IP addresses. We then have a NAT server, and this NAT server is also kind of almost a form of a router. It actually has two IP addresses. It has two network cards, really, I should say. And one is connected to the internal network, and that network card on the internal side has an IP address of 192.168.10.200, and that internal IP address is used to be able to communicate with the other internal private IP addresses. But it also has an external IP address, and here I've just randomly picked an IP address of 131.107.56.103. Okay, so that is a valid external routable IP address. And that box's whole purpose in life is to take requests from the client. So let's say client 1 wants to go out and hit a certain website. When it makes that request to go out on the internet and hit that website, it sends the request to the NAT server. Okay, so it just simply sends it to 192.168.10.200. That's all the internal client knows how to do. That NAT server will then take that transmission, the packet of information, the request for the website, and it will change the source IP address from that 192.168.10.101. It will change it to its own external live IP address of 131.107.56.103. And then it will put in its own memory, it'll do what's called cache that request. It'll say to itself, okay, I know that client 1 was looking for this particular website. So the NAT server will then send the request out onto the internet using the valid external internet IP address. And then you have this web server out on the internet. I have it listed with an IP address of, again, this is just random, 216.105.60.242. And when it responds back to the NAT server, right, because that web server, it doesn't know anything about that internal client. It only knows about the NAT server. It thinks that that's where the request came from. So it sends a response back to the NAT server. The NAT server then receives that request and says, who was looking for this website? I look at my cache in my memory and I say client 1 was. So I retranslate the IP address and send this response back to the original requester, which was client 1. That's how NAT works. And I will tell you that that's also how I can be here in my office and have an IP address on my computer of, let's say, 192.168.10.101, and you can be in your office sitting where you are, and you can have a computer with the IP address of 192.168.10.101. Okay, so your computer and my computer both have the same IP address, yet we can both still communicate within our own networks and out on the internet. And that's how we can expand, that the quantity of IP addresses to pretty much an infinite number. Okay, there is no defined maximum because, well, we can have a million of us out there that all have 192.168.10.101 on our computer. And through network address translation, it goes out to a public IP address. Now, you still might be thinking to yourself, well, wait a minute. If it was that same 1-to-1 type ratio, you got to have a public IP address for every internal one. Well, no. If you look at the diagram here, this is a very small network, but this example, I have just 3 computers, but all 3 of them, 10.101, 10.102, and 10.103, they're all going to be looked at by the internet as being that one single 131.107.56.103. And I could put hundreds, possibly even thousands of internal computers through a single NAT server on that one single internet IP address. So start doing some of the math there. You say, well, there's 4 billion valid internet IP addresses, and let's say each one of those through a NAT server could service, let's just keep a nice simple number, let's say 1,000 internal computers with their own internal IP addresses. We'll just do the math. That 4 billion, if you multiply that by 1,000, suddenly becomes 4 trillion. And now you have a number that's a little bit more realistic to the number of devices that need to have IP addresses.